What is happening, people? I hope you are doing great. Whew, 4-6. I apologize for how long this is going to be. I don't really know how long it is. Look, if you're fast forwarding through the video and you see me like waving around, going stop, okay, that means I'm going to say something important. So rewind to that, watch it again, or watch it for the first time. Anyway, got some new words here, just like we did in 4-4. Got some new words here. So best fit line. So here's the problem with scatter plots, guys. Well, there's not a problem with them. The problem becomes when we each draw our own line of best fit. That's the problem with it. I might have a line of best fit, and then you're going to have one different, right? And then this person over here is going to have a different one. They're all not going to be exactly the same, which means when I go to write that equation, we're all going to have different equations, which means when we go to use those equations, we're all going to get different numbers. That's bad, okay? So today, again, we're still going to talk about our best fit line, and sometimes you'll see them call it a median fit line. Look, we don't, it's all the same stuff to us, right? There are small differences in the calculations of a median fit line versus what we're going to do for our line of best fit, which is what they call a regression equation, okay? Again, linear regression because we're dealing with linear, like straight lines. Correlation coefficient. Ooh, okay. We do need to talk about this. Correlation coefficient. Also, little letter of the alphabet R. This shows me, right, how strong or how weak, right, the best fit line is fitting the data, right? They're going to make a best fit line regardless of if the data is really good or really bad. How good that is, the stronger this is. Guys, our values can only be between -1 and I'll say 1. Okay? So it's just a number. Okay? Where do we decide who is strong and who is weak? So if you are greater than, I'll say 1/2, right, up to 1, you are considered strong, okay? If you are between 0 and 1/2, okay, you are weak. And the same is true, right, for, well, we're going to see two different kinds of numbers. Like I said, it could be -1 or it could be +1, okay? Because we could have negative association or positive association. So if we have positive association, gang, we're going to see a positive number for our correlation coefficient. We will always get one, right? It's not like, oh, sometimes you'll get one, sometimes you won't. You're always going to get one. If that number, okay, is above 1/2, above 0.5, then the data fits, right, our best fit line pretty good, right? Again, how much better? Well, the closer it is to 1 is like perfect. If you could ever get your data or your correlation coefficient to be at 1 or -1, that means the data fits it perfectly. And we probably don't even need the best fit line in that case. Okay? Okay, next one, residuals. So residuals are like the difference between the actual value and the predicted value. Okay? We are going to use our best fit line to make predictions, right? Again, sometimes within those x values, interpolation, right? Sometimes outside of the x values, extrapolation, okay? When they're inside, right, we can say, hey, the difference between the y value we thought it was going to be and the y value it really was, right, that difference in those two y values, that's what we call a residual. We don't really deal too much with those. Median fit line, okay, we talked about that, guys. Okay, hold on. Whoa, stop. Most important thing you need for today, gang, right here. Oh, no. We've lost control of the board. Hold on. It's because I'm not plugged into the right USB port. We can fix this. Did this last time. Don't know why. It better work now or I'm going to kick its butt. Okay. Beautiful. Okay. Here is the most important thing you need for today, gang. Y1, squiggly line, mx1 plus b. Okay, what is this? I don't know. Guys, this is our secret, this is the secret sauce that we will type into Desmos. when we type this in, it will give us loads of information. I mean, loads of information. You will see what it does. But we will be able to write our line of best fit or our regression line equation or your median fit line equation, whatever the book wants to call it, right? When they ask for that best fit equation, median fit equation, regression equation, this, like if you type this in, now this isn't going to give you the equation, but this will give you the two things that you need to write any equation: your slope, your y-intercept. Okay? All right. Whew. Awesome. Okay. Let me back that out a little bit. All right, here's what we got, folks. The hardest part with making these things, right, is, well, here's a table. I've got to make this table into Desmos, right? So the table shows me this person's hourly earnings in these years. Use a graphing calculator to write an equation for the best fit line of the data. Yes, absolutely. Find and interpret the correlation coefficient. Remember, that's little letter r. And let x be the, okay, here's confusing part number one. Let x be the number of years since 2008. So guys, what that means is 2008, again, x's are going to be the years, y is going to be the cost. So that means 2008, we don't want to represent with the number 2008, right? We would represent that with 0 when we go to make this table, or ordered pairs if you want to think of it that way. So guys, that means year 1 is what? 2009. Year 2, 2010. Year 3, 2011. So on and so on and so on. Don't make your table with 2008. Okay? At the end of the day, we should still get the same, we should still get the exact same like value, right? Be it correlation coefficient or anything else, but we're not going to get the same equation. Okay? We would get the same predicted value, but we're not going to have the same equation. Nobody's going to like that. Okay, so how do you put a table into Desmos? I'm glad you asked. Here's how you do it. Nope, got to go here. Probably need to get rid of that. Okay. So guys, on Desmos, you see this plus button right here, right? If you click that, you have two choices. You can add an expression, you can add a table. Which one are we going to do? That's right, add a table. All right, so we click add a table, and then this comes up. And then you literally just put in whatever data you need to in your table, okay? As you do that, you'll see it'll plot your points over here, right? There they are, all right? Remember, if you don't see them, sometimes we're going to be dealing with bigger numbers, right? Use your zoom in, zoom out buttons, okay, to find it. If you're really fancy like me, you can use the little wrench up here, and you can actually change like the window that you want to view. Like if I just want to look at x values from 0 to 20 and y values from 10 to 20. You can do that too. If you're in class, we'll probably play around that with a little bit more, okay? Anyway, guys, so I type all this in, okay? Then you come down here. Hopefully you can see this. I literally type in that weird thing, y1 squiggly line, mx1 plus b. And then, guys, I get all this info right here. Well, first off, you want me to turn on, so here, look, I will turn it on, and it is going to make for us, boom. There is our line of best fit. Again, does it fit the data pretty well? I don't know, look at it, guys. Yeah, kind of, right? I mean, look at it. It goes through a couple points. There's a couple above, a couple below, same number. I'd say it fits pretty well, right? So I'm thinking in my brain, if it fits pretty well, correlation coefficient should be a number close to 1, right? This is positive association here. All right, check this out. Can you see it down here? Under it says statistics, residual squared. I don't care about that number. I do care about the R number. There it is right there. Check that out, guys. 0.9801. Woo, that is strong. That is strong, okay? But here's what I really need. Okay, so yes, we want that part. B, M. Holy smokes, guys. Can you, like, seriously, look at that. Look at that down there. So it tells me B and M, right? What are those? Well, that's slope and y-intercept. Can we write an equation now? Yeah, this is like the easiest thing ever, right? Because they gave me those two, okay? So look, all I have to do is try to remember all three of these numbers so I can come back here to the other slide and answer everything. Actually, I don't have to do anything. Watch this. So here, I gotta make this go away though. All right, so guys, I'm gonna say here. So our R value was 0.98, right? M 1.21429. That seems like a very large number, long number, I should say. Okay. All right. Here you go. We can make this stuff all go away, and now you can head back there. Haha. See, I knew if I wrote it somewhere, it would clearly be in the way. All right. Whew. So let's write the equation first off for the best fit line. Again, it didn't say what form to write it in, so we're just going to put it in slope-intercept form. So y equals, then you got to take your slope, guys. And, they don't really give us any rounding instructions. So I'm cool if we go probably out, 3 decimal places is going to be probably sufficient. So I'm going to say 1.214x, and then plus or minus your y-intercept of 8.25. So plus 8.25. Okay. All right. There we go. There is our regression equation, median fit equation, line of best fit. Don't care what they call it. That's what we're going to give them. Okay. Did that. Find and interpret the correlation coefficient. Okay. Correlation coefficient was 0.9. Whoa. I can't write all of a sudden. Was 0.98. Interpret that. Well, is that number above 1/2? Yes. Is that number very close to 1? Yes. Super strong, right? So this is very strong. So what does that mean, guys? Well, that means that trend line fits the data super, super well. I mean super well. Okay? Very well, like almost perfect. Okay, and you saw that, right, when we had our trend line there. Okay, so that's it for now. Okay, so we answered all those questions. That's good. Let's see what else. What are the kind of trouble we can get into here? We good? Did we move on? Yes, we did. All right. The table shows the average body temperature in degrees of 9 insects. Gross. At a given temperature. So like the outside temperature is this. These are all in Celsius, by the way. And then the temperature of the insect was that. So like, does the outside air temperature have any effect on the temperature of the insect? Does it make it colder or warmer, or who knows? It says, using a graphing calculator to write the equation of the best fit line for the data, name the correlation coefficient. Okay? So guys, we're going to do the same thing. All right? We're going to figure out what those two are. Good news for you, I've already got everything set up, I think. Bam, here you go. Again, here's my table I made. Hit the plus button, make a table. All right, let's go ahead and turn on our line of best fit. Again, looks pretty good, right? Got some data points here. We got a couple below, a couple above. It seems pretty good. So let's go ahead. I'm just going to write everything literally from this screen, guys, because it's a little bit easier. That didn't help me at all. So again, here's all my important stuff. B, M, R. Okay? So we will write our equation first. All right? So my equation, guys, is just going to be same thing, y equals. I'm going to go 0.9. Can you round this a little bit? I would be perfectly fine if we rounded that to 0.95. Okay? Plus my y-intercept, 1.53. Again, do we need to put all those extra ones in there? We can. I mean, it's going to make, if we go to use this equation, probably the more numbers is more better, right? But we're not going to use it just yet. Correlation coefficient, guys, 0.97. So interpret that. Miss Maley's here. Do you guys want to see Miss Maley? Come to A. We're making correlation coefficient and trend line data. Look, she's brought me a little present.
I did.
She knows I'm a sucker for a donut on a Friday morning.
He's a sucker for a donut at any morning.
Yeah, well, she's not wrong there. Anyway, so guys, 0.97. What is that? Is that strong or weak? Duh. It's like me, super strong, okay? If it was like 0.07, then that would be like Maley, a little bit weak there, okay? Anyway, so there's our equation. There's our correlation coefficient. Let's hop back over here. Yep. that looks good. Guys, we're only halfway through these slides. Can you believe this? Good thing there's a, well,
Mackerel.
it's a long day. It's a long.
Teach him pick your donut.
Ooh, I get to pick my donut here.
He does.
I should let the viewers pick. Holy cow.
You're super excited right now.
Wow. I don't even know, but this one looks phenomenal. Can I just grab this one?
Yeah. I put a little thing over on your desk.
All right, guys, check this out. Look at this. Look at this donut. Look at this thing. Doesn't this look crazy? It's got like cinnamon sugar and then what looks like some kind of awesome applesauce in there. Maylee, I take back all the bad things I say about you.
Oh.
You're my favorite Maylee ever.
Oh, great. Thanks.
You're awesome. Thank you.
Given.
All right, guys. Well, I'm going to enjoy it. We should just end the video now and get out of here. Okay. Hey, we got an Ohio question here. Kelly's Island. Anybody ever been to Kelly's Island? No? They have glacial grooves there. Those are grooves in a big piece of rock that have been made by the glaciers way back a long time ago, back when Philippi was born. He can tell you all about it. Anyway, this table shows the number of people who have traveled to Kelly's Island in all these different years. I believe they have a little bit of a typo because it says how many will go to Kelly's Island in 2115. It should be 2015, not 2115. So we'll fix that when we go to solve it. This is why we make our equations, guys, so we can answer these kinds of questions, right? We are going to predict a value, right? In this case, in the future, for how many people we think are going to go there, right? This, like all you complain about, oh, math never going to do anything. Like this kind of stuff probably helps some people, maybe in the tourist industry, figure out how many people are going to come to a certain place. Anyway, step one, put all your data into Desmos. Like magic, guys, I just did that. Did you see it happen? Did you see it happen? No? Too bad. Here it is right here. Again, hit the plus button. Notice, right? Now, it didn't tell me. Sorry, I'll get back on camera. It didn't tell me what to use, right? Like, hey, let X be this year, right? Starting years since this. But I find it very easy to do that. I want to be clear. You're still going to get the same predicted value when we use the equation, but what's different is that your equation is going to look totally different. Totally different. Think about it. Our slope number is going to be way off, because we're using different x values, right? Slope is y2 minus y1 divided by x2 minus x1. So when that slope number is different, it's going to change. When your bottom x values are different, it's going to change the slope number. Anyway, I'm sure you've already looked ahead to be like, oh, check out all this fun stuff over here. Here it is. So guys, I just called the first year that they had data and then put that, and then the second year with data, and third year, and so on and so on. So let's turn on our line. Okay, dots are getting a little bit more spread out here, right? Still a positive trend. Most of our trends are positive, gang. But my dot, like look at this dot's way off the line. This one's way off the line, okay? So again, the further away you get from this line, sometimes we can call you an outlier. I don't know that we've seen any outliers yet, but you know, an outlier is caused by. Ooh, Mr. Mon, if we dressed up for Halloween, it's red and gray day. I'm showing my spirit. I apologize. Okay, anyway, let's write our equation for starters, gang. Here we go. So here's all the data that I need. Go away. Bam, bam. What we were talking about correlation before Mr. Mon rudely interrupted us. And guys, look at it. So here, again, we see that the dots aren't getting as close, right? You probably can't see it. My correlation coefficient, 0.7115, okay? Still fits the data well, but now it's starting to get weaker, okay? Our first two examples, pretty strong. We're never really going to see data that fits that well, right? Then we get here, like we're becoming weaker, all right? M and B, so let's write our equation here. So y equals 68.7x plus 1086.2 and 2/10. Sorry for my sloppy writing this morning, okay? So once again, folks, the hard part is A, remembering y1 squiggly line mx1 plus b. That's not easy. You just got to commit that to your brain. I guarantee you on your state test, they're going to give you one of these. And all you got to do is remember that. And I'll show you some other cool uses for that, but not right now. Okay, so now I think we get to use this equation. So guys, we've been writing them. We haven't used them yet. All right, we will get to use them finally, right, to figure out this is not the right number we should be using here. This should be a 0, right? 2015, okay? So if we're going to use that, now we have to be careful. I changed my x values, right? I called this year 1 and this year 2 and this year 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10, okay? That's what I did. If I don't choose to use these years, and sometimes they're going to tell me what to do. Here they didn't, so we get to choose, right? What do I call year 2015? Well, if, right, year 2000 was 1, and year 2001, right, was 2, and this was 3, this is 4, right? So if I take the year and I subtract it from 1999, right, whatever I get, that's what I use. So we're just going to take 2015, subtract it from 1999. I won't pick on anybody today. We get 16. That's what I need to use for my x value, right? So here I'm replacing x with 16, right? Everybody else stays the same, plus 1086.2. I want to be clear, guys. It doesn't matter what number you used for x here. This next part, we will all get the same number. Look, I can't do that. You want me to do that kind of math, folks? That times 16, no, plus 1086 and 2/10. Okay, here we go. So here's the expected travel, right? 2185.4. So in the year 2015, we would anticipate, can we have 4/10 of a person? Absolutely not. So we should probably round this number. I would assume to round it down. So in 2015, we will predict that there will be 2,185 visitors or tourists going to Kelly's Island. That's why these equations are somewhat useful. How am I doing on time? Holy smokes, 22 minutes. You guys are hating me right now. Okay, I'm going to fast forward. Look, I'm going to throw a curveball at you. You ready for your curveball? Me either. Okay. Good news. We just did that. We only have one slide to go, guys. Okay? There's your curveball. Okay, here's our last one. Table shows the points earned by the top 10 bowlers in a tournament. Clearly, I was number 1. Okay? Estimate how many points the 15th ranked bowler earned. So they tell me, hey, rank 1 is this many points. Rank 2, okay, less points, right? Because we're not as good of a bowler. So the numbers are going down. Think about what that's going to look like on a graph. Okay? So they give us the top 10. We're estimating or predicting the 15th place bowler. All right, Desmos. Bam, make that one appear. Okay? And like magic, guys, here it is. No, I want to be still a mouse. I want to turn this on. Bam. So does that fit our data pretty well? Yeah, I'd say it's not too bad. Okay? So a couple things to talk about. Guys, try to look in down there, zoom the video, or do whatever, right? Our correlation coefficient, a negative number this time, right? So our R value is a negative number, 0.9, oh, whoa. It's negative 0.913, okay? That makes sense. Why? Well, this line has negative slope, negative correlation, negative association, okay? So we expect that number to be negative. Now, 0.9, again, the closer you are to -1, the stronger you are. So does this line fit the data pretty well? Absolutely. Absolutely. Okay? Again, we're trying to predict the 15th place bowler. That would be Mr. Knoll. He's not a very good bowler. All right? Here's our equation. Y equals, my slope, guys, is -7.87 and a whole bunch of other numbers. I'm good with probably just those two. Plus 201.2. Okay? Think about it. So this is the, hey, you start here, and I need an X here. Every place, you're going to go down 7 pins, almost 8 pins, okay? So if you're the 15th place bowler, right, we are going to replace X with 15, do a little bit of math, okay? You guys ready for this? 7.87 times 15 plus 201.2, right? You can be writing this on your slide. Again, I don't know what that number is, gang. It's too early in the day. Negative 7.87 plus I have that great donut over there to go get to. And then we're going to add 201.2 to that. So the 15th place person, right, again, mathematically, would score an 83.15. Of course, for all of my bowling experts out there, you know you can't have partial pins in your score. So we would just say, hey, the 15th place bowler is going to bowl an 83. That's, I don't know, maybe that's good for some people. Who's to say? I don't know. All right, guys. Anyway, there you go. I apologize for the length of this video. Hopefully you realize how useful Desmos is to make these lines, and you're using all of our M and B and kind of understanding what correlation coefficient little letter r is. So it's Friday morning. We're going to have a great day today. I hope you guys are doing the same thing as well. See you.